Hello dear students, welcome back to NEET WORLD. So we are continuing our discussion on solutions chapter using PYQs. I hope you are following our sessions daily in this NEET WORLD YouTube channel. So we have started this around on November 1st and we have almost completed 4 units, 4 chapters from this chemistry part, okay, and similarly from botany as well as from the physics. Right now, I hope you are using these live sessions very effectively for your upcoming EAPCET 2026, okay. And guys, even if you are preparing for JEE or upcoming NEET exam, these sessions are highly helpful because in EAPCET, same concepts are involved right now, and in this EAPCET, if we consider the syllabus of EAPCET is more than that of JEE as well as NEET exams right now. So if you follow the theory that we are discussing here and as well as the questions that we are doing here, the PYQ questions, we are selectively picking up the questions from the very important topics like that are asked in the previous year exams, okay. So that must be done by every aspiring student for upcoming EAPCET, okay. So if you are the one who is preparing for EAPCET very seriously, so just follow these sessions regularly so that you will definitely make your preparation more effective than the others, okay. And you can share with your friends if you like our content, okay. First, let us discuss about the solutions. In the last sessions, this is our third session, okay. So this is our the PYQ session, which is our fourth session on these solutions. So what we have discussed in the previous sessions, so in the first session I have discussed types of solutions and Henry's law. So one of the very important topic for EAPCET, Henry's law, okay. And after that, in the second session, along with this I have discussed in the first session, along with this I have discussed concentration terms. See, there will be one definite question from this concentration terms, okay, right. And if you want more number of all the concentration terms along with the discussion that we have done in the solutions, I have specially made a session on this concentration term, you can watch it also, okay. And after this I have discussed about Raoult's law in the last to last session, Raoult's law, okay. This is our second session, Raoult's law and ideal solutions, Raoult's law and ideal solutions, ideal and non-ideal solutions, and along with that I have given a touch on these azeotropic mixtures, okay. So because we can expect questions from this azeotropic mixtures also, okay. And after that, the last session, it means yesterday's session, I have covered colligative properties. What is that? Colligative properties, okay. So these are the very important topics for any type of exams, whether maybe EAPCET, JEE or NEET, these topics must be solved. These are all the topics that must be completed from the solutions, okay. All whatever I have highlighted here, all those are very important. You should not skip any of this topic from the solutions chapter, okay. So like this, from each and every chapter, you just segregate the important topics first, then you can make your preparation effective from that, okay. After completing one particular topic, for example, you finish this Henry's law, definitely you should need to solve some questions like what are the different model questions they are asking from this Henry's law. You should cover all those model questions, okay. There will be some theoretical questions and some numericals, you must cover both of them, okay, right. And next, let me discuss about some PYQs today. So I hope you have watched my previous session on this colligative properties. If not, I suggest you to watch it without ignoring it, because highly helpful for your upcoming preparation, upcoming exam. So let me show you one question first on colligative properties, because we have discussed in the yesterday's class only. So once after finishing that, we will go for the other questions of these solutions. See, consider the following aqueous solutions. These are the 4 aqueous solutions given, and assume 100% dissociation in all these cases. Consider all of them are undergoing 100% dissociation if they are electrolytes. Then answer the following. So what will be your answer? Solution with highest delta TB. So tell me which solution will be having more highest elevation in boiling point. Very simple guys. What are the formulas we have learned for elevation in boiling point, depression in freezing point? See, elevation in boiling point directly proportional to the molar concentration right now. And next, one more factor is there. This is what? The Van Hoff factor I. Okay, so these two things must be considered in all of these options. Okay, so even if I ask for any colligative property, it can be delta TB, delta TF, RL, VP and osmotic pressure. All these are directly proportional to their molar concentration or molarity, or the concentration simply, and multiplied with Van 't Hoff factor. See, in all these four options, the concentration remains fixed right now. So now if you observe this NaCl, it's an electrolyte which can undergo dissociation to form two ions, Na plus and Cl minus. So the Van 't Hoff factor in this case will be 2. Okay, and similarly this will be giving Van 't Hoff factor 3, and here it is 4, and this will be urea. Urea is a non-electrolyte now, it won't undergo any dissociation, therefore I value will be 1 only. For non-electrolytes it will be 1. Okay, so now since concentrations are same here, so you can decide your answer with respect to Van 't Hoff factor I itself right now. So which one is having more Van 't Hoff factor? C, that's it. So you can say option C will be highest delta TB value, then after that B, and after that A, and least is for D, that's it. This will be your answer, whether it can be delta TF and whether it can be delta TB, because they are directly proportional to I, right, Van 't Hoff factor. And the next one more factor, one more question here, the solution with highest delta TB. Very simple, delta TB means what? The boiling point of solution should be highest, they are asking here right now. So it means you can write delta TB value as T S B minus T naught B, which is equals to IKBM right now. Okay, if you do not knowing this formula, just go and attend my watch my last session, that is yesterday's session on colligative properties. Okay, very useful whether you are preparing for JEE, NEET, EAPCET, no matter, everything is covered in that. Okay, right, with a crystal clear explanation I have covered. Okay, so elevation in boiling point of solution will be equals to, see, I can send this delta TB naught to that side, so it becomes TB naught plus IKBM. Okay, so it means what? See, the elevation in the boiling point of solution will be equals to the boiling point's pure solvent plus some value is added. So this value will be more if I value or M value is more. Since I values are more in these cases, that will be having more boiling point of solution. The boiling point of solution again follows the same order as the above. Okay, and the next, now if I ask solution with the highest freezing point, so when it comes to freezing point, so delta TF we have now, so delta TF means what, in what way you are writing? TF means TS TF naught minus TSF TFS, which is equals to IKFM. Okay, so what is this T naught F is representing? The freezing point of pure solvent before adding solute, and this is what? Freezing point of solution that is made by mixing solute into the solvent right now. So now I am asking TFS. So what will be your answer here? So simply take it that side and bring that this side. So it becomes TF naught minus IKFM. So simply what you are observing here, see, the freezing point of solution will be equals to freezing point of solvent minus some value. So minus this value. So it means freezing point of solution will be definitely lower than the freezing point of solvent. That's why we are saying depression in freezing point. Now how much amount it is decreased or depressed, that depends upon its molality, that is what, concentration and Van 't Hoff factor I. If more is the Van 't Hoff factor, more is the depression, more is the decrement in the freezing point of that solution. So where do we have greater I value? Greater I value is in the case of this third option. So more I value, more is the depression. So freezing point will be least for this option C. Okay, so least for C. After that I value is more for B, you can write it like this, and the next A, and least will be, the least I value is for urea, it means it will be having highest freezing point. This one D, highest freezing point is for which one? For option D. Okay, I hope it is clear. It means what you got to know, the freezing point of solution, the freezing point of solution will be inversely proportional to I. Why it is inversely proportional? Just for relation purpose I am saying inversely. So why it is in this inversely proportional? Because TFS, wave freezing point of solution, is equals to minus of I, right now. So more I value, lower will be the freezing point of solution. That's it. Hope the concept is clear using this particular explanation and with particular example. Okay, I hope whatever the question comes in this manner, you can easily answer. For more clarity from your side, so just tell me what will be the osmotic pressure order for the same question, or this question you tell me. Say I have 0.1 molar glucose and 0.1 molar next what I am taking here is 0.1 molar NaCl, and the next 0.1 molar MgCl2. Okay, very simple guys. For your understanding purpose, tell me solution with highest pi, I means osmotic pressure. See, what are the colligative properties? We know there are 4 colligative properties, right? One is RLVP, relative lowering of vapor pressure, and delta TB, and the next delta TF, and the next pi, osmotic pressure. These are the 4 colligative properties. All of them are directly proportional to I value. If their concentrations are same, then their answer will be given with respect to the Van der Waals factor I only. Okay, if concentrations are different, you multiply Van der Waals factor I with their concentration. Greater this the net value, greater will be their colligative properties. Now tell me, pi will be maximum in which case here? Say glucose is a non-electrolyte having all of them are same concentration. Now these two are strong electrolyte, but when MgCl2 is undergoing dissociation, it can give a 3 ions, one Mg plus 2 and 2 chloride ions. Totally 3 ions are formed. So more number of ions, more is the Van der Waals factor, more will be the colligative properties. So pi will be greatest for this MgCl2. So maximum is for MgCl2, and after that NaCl, and after that glucose. That's it. Hope this is clear. This could be the way of understanding and way of applying the knowledge on this particular osmotic pressure, or what might be the colligative property maybe. Okay. Now I will be asking you the same question in some different manner. See what I am giving you, 0.1 molar glucose I have given, and 0.1 molar urea I am giving you. So tell me which will be having more pi value, the order of pi in this case. Okay, pi means osmotic pressure, like it is applicable for all colligative properties. Okay, so concept is you can generalize it to the colligative properties, all the remaining colligative properties also. So now tell me which is having more osmotic pressure out of these two. Very simple guys. What is the formula of pi? Pi is equals to I Cm St. So what is this Cm here indicating? That is molar concentration, molarity, right? And what about I value? I is nothing but Van der Waals factor. Since urea, glucose, both of them are non-electrolyte, I value will be 1 in these two cases, in these the two compounds here. Okay, and I am asking their order, I mean which is having more osmotic pressure. It means I am doing this thing comparison at same temperature. So temperature and this S are a constant. So everything is constant now. Pi is directly proportional to its molarity, molar concentration, that is given as Cm right now, molar concentration. Okay, right. So now molarity formula you know now. What is the molarity formula? Number of moles of solute by volume of solution in liters. So since solution it is made up of the water as a solvent, so the aqueous solutions only. So no need of worrying about this concentration like volume. Now look at this number of moles. Number of moles I can write weight of particular solute by their molar mass right now. So if molar mass of solute is more, colligative properties will be less. So I can say colligative properties are inversely proportional to their molar masses of their solutes right now. So out of these two, we know glucose molar mass is 180 grams and urea molar mass is just 60 grams. More is the molar mass, lower will be the colligative property right now. So the colligative property, the osmotic pressure of these glucose will be now less than the osmotic pressure of urea. That's it. I hope you got the concept. And what way they can expect or they can ask us the questions for these colligative properties. Hope this is clear, right? If this is clear, just click on the like button guys, and if you really like the content, just share with your friends also, okay, right. Let me move forward with few more questions. See, I have one more question here from the osmotic pressure only. Just tell me from EAPCET exam. Yes, tell me what will be your answer for the question. Anyone can try. Right. So just answer me for this question. So what they are saying, the osmotic pressure, is this visible properly? Right. Let me zoom it out. So what they are saying, the osmotic pressure of sea water is 1.05. So pi value is given as 1.05 atm. Okay. The 1.05 atm. 4 experiments were carried out as shown in the table. I will tell you the table. Okay. The following experiment, in which of the following experiments the pure water can be obtained in part 2 of the vessel. Okay. Right. So part 2 of the vessel. See, there are two parts here. One containing sea water, other containing normal water, pure water. Okay. And these are separated by semi-permeable membrane. Now what they are saying is, they have did 4 experiments. I mean, on this they have made some 4 experiments here. So now what they did is, they applied pressure of 10 atm part 1, and in second experiment in part 2, and in third experiment 15 atm in part 1 and 15 atm in second part in fourth experiment. Like that they did this experiment. They are saying, how can we make the purification of water? That means sea water should get purified. It means now what should happen, this water from this salt water, sea water, pure water should move from here to here. Solvent should flow from sea water to this pure water side. So how this will be possible? See, what do we mean by osmotic pressure? Osmotic pressure means the spontaneous flow of solvent molecules, from lower concentration to low concentration to high concentration. So low concentration to high concentration of the solution should happen spontaneously. This is what osmotic pressure. See here, in both cases, this is water, here also sea water. It means sea water, what is the solvent here? Sea water. So water will be the solvent and solute will be the salts like NaCl. See, we know sea water will be salty taste right now. So the minerals, whatever NaCl, MgCl2, whatever the salts are there, that will be considered as solute particles. The remaining water will be there, na, that main solvent it will be. Okay. Now osmosis means what? Flow of solvent molecules only, no? Right. But from where to where? Osmosis happens from lower concentration. If this is a pure water, it means no concentration now, no concentration of any solutes. So it means lower concentration to high concentration takes place, that is osmosis. But what we require, the sea water should get purified. It means this should move from here to here. So how that will be happens? Very simple guys. So when osmosis is taking place, the pressure, osmotic pressure created is 1 atm. So now in order to make this purification, you just need to apply the pressure, higher pressure than this osmotic pressure on this sea water, because osmosis happens from this pure water to sea water right now, low concentration to high concentration. So if you apply higher pressure from this piston on the sea water, the osmosis will be taking place from high concentration to low concentration. That is what the reverse osmosis can happen here. Okay. So if you apply the pressure, external pressure greater than the osmotic pressure on the sea water high concentration side, solvent molecules will move from higher concentration to lower concentration. So this is how we can purify the sea water to the normal water. Okay, right. The very important application. So where do we need to apply? We need to apply the pressure on the part 1 side, so that solvent molecule will move towards this pure water side. That is what purification is taking place. So it will be possible, the purification of water will be possible by applying 10 atm pressure of first part 1 side as well as not part 2 side, because that will make normal osmosis only. Again, wherever you are applying pressure on part 1 side more than this one, their osmosis, reverse osmosis taking place. So part 1 and this experiment 1 and experiment 3 are the perfect answers. It means option A will be a suitable answer for this particular question. Hope this is clear. Right. Let me explain you this other colligative properties also. See, the delta TB value for 0.01 molar KCl solution is 0.01 Kelvin. What will be the Van 't Hoff factor? See, again EAPCET question, very simple question guys. See, delta TB will be equals to I kbm right now. So I value is how much for this KCl? So KCl is a strong electrolyte now, it can give K plus Cl minus. So consider 2 ions will be obtained, so I value will be 2. Okay, I value will be 2. Okay, 2 into, what about kbm value mentioned? Kbm is given as 0.52. Okay, so what they are asking? What is the Van 't Hoff factor only they are asking, na? So again, look at this. I have mentioned I value as 2. Directly you can answer in this way. The nearest option for this will be A is there, you can directly answer that. But they haven't mentioned that whether it is 100% dissociation. They haven't mentioned whether it is 100% dissociation or 70%, 90%. They haven't mentioned, na? So we cannot directly take it as 2. So in order to get how much extent it is undergoing dissociation, then we can find this I value. So simple here, I want I, right? So I can write delta TB by kbm. Okay, so now look at the data they have given. Delta TB is how much? Delta TB value for this solution is 0.01, that's it. Okay, and what about kb mentioned? It is 0.52. And what about molality mentioned? 0.01, that's it. See, these two terms are same. We got 1 by 0.52. So this will be simply, you can say this will be 10 by 5.2. It means this will be 1 time. Okay, and we have 4.8. It means 9 times. Okay, 1.9. Where do we have 1.92? Yes, first option will be a perfect answer for this particular question. Hope this is clear. And see, you can directly answer in this way, but the perfect exact answer in order to get, this is the best way of doing the question. This is the only best way of doing the question. Okay, so if we take like this, it might be error because there will be 2 values, nearest values. We cannot predict which one is correct. Okay, it depends on the values that we got, delta TB value we got by inserting I. Okay, that's why you need to substitute in this formula, then only you calculate I value. Okay, right. Let me move forward with one more question on osmosis. Very important it is, very conceptual, very easy. So if you understand the basic definition of osmosis, you can answer this kind of questions. See here, what they are saying, there is a container which is separated into 2 compartments which are separated by SPM. This is semi-permeable membrane here, okay, which allows passage of solvent molecules only. Now look at the statement what they are saying. So in one container they have taken FeCl3, other container this ferrous cyanide complex is taken, compound is taken, having some 0.1 concentration, 0.01 concentration. Now they are saying FeCl3 on reaction with K4FeCN 6 times is in aqueous solution gives a blue color, Persian blue complex is formed here. Okay, and these are separated by a semi-permeable membrane AB as shown. Yes. Okay, so due to osmosis there is, now what happens due to osmosis, is there any blue color formation in side X or blue color formation in side Y or blue color formation in both of these or no color formation? So how can you answer this? Very simple guys. Now look, osmosis means what? Flow of solvent molecules only now. So solvent molecules from where to where? Solvent molecules will only move from lower concentration to higher concentration. See, both of them are having some concentration, and in both of these solutions, what is the solvent here? Water will be the solvent in the both cases now. It means movement of this solvent, water molecules may only takes place from here to here or from here to here. there is no movement of this solute iron particles na, or this complex particles na, therefore there is no blue color formation in any of this compartment. Therefore what will be your answer for this question? Fourth will be the option, fourth will be the perfect answer for the question. Hope this is clear, right. Let us move forward with few more examples. Can you answer me this question? Very simple, very simple question. Again you just give a try. If you are unable to solve that, I will explain. Okay, so tell me, have you got the answer for this question? See, 2.56 grams of sulfur in 100 grams of carbon disulfide has depression in freezing point of 0.01 degrees Celsius given Kf. Okay, so what we need to find? Atomicity of this sulfur. See, very simple, atomicity of sulfur in the solution. Very simple. See, how many sulfur atoms? See, actually we know, if you have already seen about sulfur, you directly answer this question, because standard form of sulfur existence will be like Se8 right now. So 8 will be your answer, directly you can answer in this way, but properly, like what is the concept involved in it, let us see here. See, because sulfur has different allotropic forms here, so based on that you can answer this as 8, but let me explain you the proper way of approach for this question. See, the given delta TF, they are discussing about depression in freezing point. So write the formula first, basic formula. See, sulfur, it is non-electrolyte, here you can consider I value will be 1. So KFM, that's it. After doing this, Kf value is given as 0.1, that's it. Next, what about M is mentioned here? See, 100 grams, molality means what? Number of moles of solute are present in 1 kg of solvent. So number of moles of solute here you can take. How many grams it is mentioned? 100 grams of solute is given. And what is the molar mass of carbon, the sulfur? You just consider it as molar mass as it is, molar mass of sulfur. We need to find this, okay? And 1 kg are present in how many grams? Okay, look at this, 2.56 grams of sulfur in 100 grams, right? Okay, so weight of solute is given as sulfur weight is given as 2.56 grams, present in 100 grams of carbon disulfide. If you are making it in grams, you just multiply this with 1000. It means what? Here you take 1000, that's it. Okay, and what about delta TF is mentioned? See, has a depression in freezing point of 0.01. So this is 0.01. Okay, so simply what you can say, so this will be 2 zeros, here 2 zeros, okay, and this 0 cancel, here we have 10 power minus 1. So I can ignore this, I can simply write this as 256 right now. So molar mass, how much we got for these? 256 grams we got, 256 gram per mole. Okay, so now if there is only one atom of sulfur is present, it will be having a mass of 32 grams right now. Okay, I mean 1 mole of sulfur atoms are present, we have 32 grams, but we got it as 256 now. Just divide this 256 with 32. So how much will be your answer? So this will be simply, you will get around 8 right now, 8. So 8 will be your answer, means so fourth option will be the perfect answer for the question. Hope this is clear, right? Let me move forward with few more questions. Look at this question. At 0.2 molar aqueous solution of weak acid HX is 20% ionized. Its freezing point of solution is. See, very simple again. So what to do, I will tell you one basic approach for this, you can follow for further. Okay, so what to do, freezing point of solution. So delta TF is equals to, okay, so what you can write, TF naught minus TFS is equals to IKFM, that's it. Okay, so what they mentioned, 0.2 molality is given, small m is given, and weak acid 20% ionized. It means alpha D is 20. It means 20% means you can take 0.2 degree of dissociation. So find I value from that, I equals to 1 plus n minus 1 alpha D, right? So 1 place, see when that HX is undergoing dissociation, we will get H plus and X minus. So 2 ions will be formed, 2 minus 1, 0.2, that's it. So 1 place 0.2, that is 1.2. This is the I value we got, right? So we got I value also. The next Kf value is also mentioned. So you got I 1.2, Kf is 1.86 and M given is 0.2, that's it. So you can just multiply all these things, you will be getting your delta TF. Now after that what we need to find? We need to find this thing now. So what to do? So this TFS will be now equals to T naught F minus this term, okay, this term. So that you will get one of this option. So now all of them are in degree Celsius now. So it means TF, see this is aqueous solution mentioned means what is the freezing point of water? 0 degrees now. So it is nothing but 0 minus this thing. So 0 minus this complete calculation you will be getting around 0.45. Okay, so it means freezing point of solution will be how much? Freezing point of solution is minus 0.45, that will be option 1. Okay, you can cross check this and you can tell me your answer in the chat box whether it is correct or not, right? Hope the concept is clear here, right now, right? Let us move forward. Again, this question I have discussed in the previous session also when I am explaining the basic understanding of colligative properties, right? In the last session it was already discussed. You can watch the previous session if you haven't. Right. Next question here. Right. Look at this question from NEET exam also. I have brought few questions. If the molality of dilute solution of if the molality of dilute solution if doubled, the value of molar depression constant Kf will be. See Kf, this is molar depression constant or cryoscopic constant we can say. So it is independent of solute particle. It depends only on nature of solvent. Okay, what it is? It depends only on nature of solvent. So even if you the molarity of dilute solution if doubled. So even if you increase the concentration or decrease the concentration of solute, there is no effect on this Kf value. So it remains unchanged. What I am saying, it remains unchanged. Next, which are the following is depends on temperature. There are 4 concentration terms. Whenever in a given concentration term, if there is involvement of volume term, that will be temperature dependent. So molarity is a temperature independent, temperature dependent. Why I am saying it is temperature dependent? Write the formula of molarity, number of moles by volume of solution right now. So volume term is involved now. So upon increasing temperature, volume expansion takes place. So expands, volume increases, molarity decreases. So first term is temperature dependent. Next, mole fraction, molality, weight percentage. All of them are having weight of substance or number of moles of substance. Therefore, there is no volume term in 2, 4, 3 options. Therefore, these are temperature independent. Okay, only option 1 will be perfect answer. Next, the mixture that forms maximum boiling azeotropes. How can we identify maximum and minimum boiling azeotropes? Very simple. Maximum boiling azeotropes are those compounds or those mixtures which shows maximum or large negative deviation. Solutions which shows large negative deviation here is, see, water plus nitric acid is a negatively deviated solution. So this will form maximum boiling azeotrope. Now ethanol water will form positive deviation, and if you do not know how to identify whether it is positive deviation or negative deviation, I have clearly explained in the previous session. It means previous means second session on this solutions in this EAPCET series. Okay, EAPCET 2026 target series. Just go through the playlist and you can watch it. You will get complete clarity and you can solve maximum questions. Any question from the PYQ almost can be solvable, like you can answerable. Okay, once if you watch this. Next, acetone plus carbon disulfide. So this will also forms positive deviation. Okay, and heptane octane, both of them are having same intermolecular forces, na, similar, therefore it forms ideal. So only negatively deviated solutions will form maximum boiling azeotropes. If it is positively deviated solution forms minimum boiling azeotropes. That's it. Very simple, guys. Next, look at this. For an ideal solution, the correct option will be, again we have solved this kind of model questions in the discussion of ideal solutions, Raoult's law. See, for an ideal solution, delta H must be equals to 0, delta H mix, delta V mix also should be 0, and entropy mix, whether it is ideal, non-ideal, whatever might be. So delta S mix for the system should be greater than 0. Okay, and delta Z mix should be less than 0, negative, for a spontaneous process. So now look at this. Delta S mix, they are saying 0. No, it is incorrect. This is not equals to 0, incorrect. Delta H mix is 0. Yes, this is correct. Next, what they are saying, delta G mix is equals to 0. It should be less than 0. This is incorrect. So option 3 will be your perfect answer for the question. Okay, right. If this is also clear, let us move forward with few more questions. Next, can you answer me this one? This one which shows positive deviation. Which one of the following will show positive deviation? Right. Very simple. The mixture which shows positive deviation from Raoult's law. Here, if the intermolecular forces between the components are same, that will be ideal solution. If the intermolecular between these components, see, benzene, toluene, having same intermolecular forces, now the structures are almost same. Both of them are non-polar. So almost similar intermolecular forces. So it forms ideal solution. Okay, and if the intermolecular forces between the components are more than their individuals, then it will be showing negative deviation. Okay, so here we have acetone plus chloroform. There will be hydrogen bonding between acetone and chloroform. So that makes it to be show negative deviation. Okay, right. Next, chloroethane, bromoethane. Yes, both of them are halide with alkyl group. So that will be having similar intermolecular forces. So it will be ideal. Okay, and fourth option, if you see ethanol plus acetone, so this will be ethanol plus acetone, making it to be having different intermolecular forces and less intermolecular forces after mixing, and shows positive deviation. So perfect answer for this particular question will be option 4. Okay, right. Let me give you a few more questions here. Right. Can you answer me this question? Both from NEET exam. Very easy questions. This is based on Raoult's law, and this is KF, freezing point. We have solved enough number of questions on freezing point of depression in freezing point of solution, or depression in freezing point, elevation in boiling point. Yes. Can you answer me this this question, second question? What they are saying? See, the correct option for the value of vapor pressure of solution with benzene and octane in molar ratio of 3:2 is how much? So what they are saying, vapor pressure of solution, PS of solution, vapor pressure of solution, that is P total of this mixture, benzene and toluene. So that is nothing but, see, they mentioned it as assume ideal solution. So it means we can use our Raoult's law. So vapor pressure of benzene plus vapor pressure of octane. That's it. This if you calculate, then you will get the answer. So how can you calculate vapor pressure of benzene in this solution of benzene plus octane? See, in this we have benzene plus octane. Now the vapor pressure of benzene you need to know in the solution, and vapor pressure of octane in this solution you need to know. So how can you calculate this? Vapor pressure of benzene can be taken as the vapor pressure of pure benzene and its mole fraction in this solution, okay, and vapor pressure of this pure octane and the vapor the mole fraction of this octane in this solution, that is octane. That's it. Okay, simple guys. Just look at here what I am doing. See, what is the vapor pressure of benzene is mentioned here, 280. Take here 280, multiply with what is the mole fraction it is given for this benzene. See, the mole fraction ratio is 3:2. It means benzene is 3 moles and total moles will be 2 plus 3, 5. Here this will be octane will be 420 vapor pressure multiplied with its octane mole fraction. How much? Number of moles of octane are 2, but 2 plus 3, 5. That's it. That's it. We are almost done with the question. So this will be how many times? 5 ones are 5, 5s are, and we have 3 here. We can write 56 here. Hope this is clear, right? So 25. Next 3 will be there, 30, so 56. And this one 8s are, and we have 20, so you can say 4s. That's it. Okay, and multiply this 18, 1, 15, 16, 168 plus, and this one is how much? 18 plus 16, 168. So this will be how much here? As per the options, we will be having 336 right now. So 336 mm of Hg, that is option number 2 will be perfect answer for the question, right? This is also clear, right? Yeah. So what do we mean by isotone? P1 or pi1 should be equals to pi2, that's it. So based on this you can calculate, you will get some answer in this, and I have solved this question in the last class, I mean yesterday's live session. You can try this. If you are unable to answer, then watch the session, okay, right. Again, plot. This is also very interesting question. Here you can see the plot of osmotic pressure versus concentration for a solution gives a straight line with slope this much. See, what is the osmotic pressure formula? Pi is equals to molar concentration into temperature to S. Okay, so they have given pi versus its molar concentration gives a straight line. Okay, gives a straight line with slope 25.73 they are saying. So what is our slope here? S into T. This, see, same question asked in NEET and JEE also similar question there will be asked. Okay, I have seen one question in the solutions in JEE also in the same way, in the same graphical representation only. Okay, so what is the value of this temperature they are asking? Very simple. Slope value is given as 25.73 liter bar mole inverse. Okay, and now see here S is nothing but universal gas constant values you can take. So temperature becomes how much now? 25.73 by 0.083. Okay, so this is liter bar mole inverse. Here also liter bar mole inverse and Kelvin inverse. So now liter bar mole inverse, and this one is removed. So our answer will be in kelvins, not in degree Celsius. We got our answer in kelvins. See, Kelvin inverse is there, so we will get kelvins. Okay, so this will be how many times? See, you can write this as 25.7. See, how many times you can write? 20. So this will be 8.35, right? So 2 decimal 273 like this you can write, or simply just look what I am doing here. 25.73 as it is, and 8.3 into 10 power minus 2 I am writing. So this will be how many times? 8.3 2s are right now, 3s are. Okay, so it means our temperature will be around 300. See this, I can write 300 Kelvin we got. So temperature is around 300 Kelvin. Okay, but no option is in terms of kelvins. So what to do now? You can convert your degree Celsius, Kelvin Celsius to degrees. So we know 273 plus our degree Celsius gives our Kelvin, temperature in Kelvin right now. So we got 300, so just 300 minus 273 gives us temperature in degree Celsius right now. So this will be how many times? So this will be how many times? It will be, see, this will be 310 kelvins. So here it will be 310 minus 273. So it will be 27 degrees Celsius. That's it. This is our answer. Option number 2 will be your perfect option for the question. Okay. Hope this is also clear. Right. Let me move forward. Can you match them? See, delta TB. Delta TB is what? Delta TB is directly proportional to what they are asking. Again, mixture of acetone plus chloroform. Mixture of acetone plus chloroform, negative deviation. So P4. Next, copper ferrocyanide. Yesterday's class I told you copper ferrocyanide is used as a semi-permeable membrane, SPM in osmotic pressure. Okay, so R2, and camphor is a volatile substance. Okay, delta TB directly proportional to mole fraction. So in that way you can answer one of these 4. Okay, next. Can you answer me this question from JEE mains? Anyone in the chat box can answer me this question from JEE mains? Yeah, if you are facing difficulty to answer this, very easy guys. I have solved this question in the first session, that is on Raoult's law. Raoult's law session, I have covered this. I have discussed this very clearly. Okay, this is second session on the solutions. Okay, you just try this. If you are facing difficulty to answer, you can watch that. Vapor phase composition concept is also very, very important when it comes to Raoult's law concept. Ideal solutions. Okay, then next, let me show you few more questions also. Read this question once. Look at this, what they are saying. Liquid A and B forms a non-ideal solution with positive deviation. What they are saying? Liquid AB forms non-ideal solution with a positive deviation. So the interactions between A and B are weaker than the AA and BB interactions. Yes, this is correct only now. So whenever the intermolecular forces between the different components like AB are weaker than their pure components like AA or BB, then they will be showing positive deviation right now. So statement 1 is perfectly correct. Statement 2, for an ideal solution delta H is equals to 0, right? Delta V mix also equals to 0. That's it. Both statements are correct. So option A will be perfect. Next. Can you answer me this question from again EAPCET? A solution was prepared by dissolving 0.1 moles of non-volatile solute in 0.9 moles of water. What is the relative lowering of vapor pressure? RLVP based question, very important concept it is. See, RLVP, how can we solve? If you are not aware of this concept, you can watch my previous session, that's it. Okay, so you can write RLVP. See what they are saying, relative lowering of vapor pressure. Okay, relative lowering of vapor pressure. See, I have a component here, solvent having vapor pressure of P0A. P0A is the vapor pressure of pure solvent, okay, which is a volatile component. This is what is that? Volatile component. So vapor pressure will be high for volatile components. To this, I am adding a solute which is non-volatile. What I am saying, this is a non-volatile. So when we add this solute B, which is non-volatile, to the solution, the vapor pressure of this solvent will decreases. That is what? Lowering of vapor pressure. Now lowering of vapor pressure, LVP, if I ask, you should write it in this manner. P0A is the initial vapor pressure of the solvent. Now lowered now, so that is PS, vapor pressure of that solution. See, once after adding this solute, this will become solution now. Solute plus solvent becomes solution. That is the vapor pressure of solution you can take. So the LVP you can write P naught A minus PS. So here relative lowering, it means what? Relative low LVP if they ask like this, RLVP if they ask, relative lowering of vapor pressure if they ask, you just take P naught A minus PS, you can relate it to the initial pressure. What is the initial pressure, vapor pressure? P naught A, that's it. This is the P naught relative lowering of vapor pressure formula. So now relative lowering of vapor pressure will be equals to the mole fraction of solute. What is that? Mole fraction of solute. So this concept, how it is related to mole fraction of solute, I already explained in the last class. Okay, why I am saying? Because again showing the derivation and all those things takes time. Okay, so those who already attended the last session might feel bored. That's why I am saying to the newcomers to watch my previous session. That's it. Okay, so there is nothing wrong in that right now. So number of moles of solute is how many? From mole fraction of B indicates what? Solute. Number of moles of solute by Na plus Nb, total number of moles. Okay, that's it. So number of moles of solutes are how many? 0.1 mole, and number of moles of solvent are 0.9 and 0.1. That's it. This is 0.9. So RLVP is equals to how much it is? Very simple guys, 0.1. That's it. This will be your answer for the question. So we have option C as your answer for the question. Right? This is also clear right now. Let me move forward. Look at this again from EAPCET. See, I am ready to solve n number of questions based on your response. Okay, I am going to solve n number of questions. Okay, so if you want, you can post your doubts. I mean, whatever the numerical problems that you are facing difficult in the WhatsApp group or in the Telegram group, that the link and details will be provided in the description box. You just share those things to the Telegram group or the WhatsApp group of our NEET World channel. So we will definitely solve those questions in the upcoming live sessions for your EAPCET, JEE, NEET preparation. Okay, right guys. Okay, and the next, especially those who are in the Hyderabad or Telangana, AP region, those who are from Telugu states. So you can also reach us to our main branch here in Narayanguda, Hyderabad. Okay, you can come here. You can, if you want to discuss further, you can come approach and sit with us, and you can discuss further for your preparation related queries. Okay, now look at this question. At temperature T, two liquids A and B forms an ideal solution. The vapor pressure of pure liquids A, B at the temperatures are 400 and 600 mm of Hg respectively. Okay, so the mole fraction of liquid B is given as 0.3 in the mixture, and mole fraction of AB in the vapor phase composition. Very important, this vapor phase composition, even if it is JEE or EAPCET, no matter, important topic. Okay, so just now I given one question as a homework for from the JEE exam, right? So same model question here we have in EAPCET. So you do not think that EAPCET is dead easy exam. Okay, no. So sometimes the questions asked in this EAPCET are far more quality or more standard than this JEE exam. Okay, even when it comes to maths, it is like unbearable. Okay, because time is less here, number of questions are more. Okay, right. So let me solve this question here so that you can solve that homework question from JEE mains. Okay, that I have given previously. So look, the vapor pressure of pure liquid AB are given. So P naught A is mentioned as 400 and P naught B mentioned as 600. Next. If the mole fraction of liquid B is 0.3, the sum of mole fractions are equals to 1 now, chi A plus chi B equals to 1. It means mole fraction of A will be 1 minus 0.3, that is 0.7. Okay, next. These are the compositions in liquid state. When I representing chi A, chi B, that is XA, XB, that is in liquid state. These are the scenarios in the liquid state. Okay, now they are asking what is the mole fractions in gaseous phase, vapor phase. YA, YB they are asking. Very simple. From Dalton's law of partial pressure, if you know the concept of Dalton's law of partial pressures and this thing, so you know the vapor pressure, the partial pressure of a gas will be equals to mole fraction of that gas multiplied with total pressure. Okay, it means here Dalton's this pressure will be this rule, I mean this law is applicable for gaseous particles only, I mean gases only, not for liquids. See, for a particular gas, the partial pressure of that gas will be directly proportional to its mole fraction. So it means what I can say, the partial pressure of this component A will be equals to the mole fraction of that component A in its gaseous phase, because these are applicable for gases only. That's why I am writing mole fraction of A in gaseous phase, Ya, into P total. That's it. So what we required here, I required this Ya. So Ya can be written as Pa by P total. That's it. We are almost done with the concept. Right. So Pa, how can you write? So Pa means what actually? Vapor pressure of A in this solution. If this is the beaker containing A and B solution. Okay. So now what is the vapor pressure of A in this solution? What is the vapor pressure exerted by this A in this beaker? So what you can say, that is indicated with Pa. Okay. So Pa will be equals to P naught A. It means vapor pressure of that pure component A multiplied with its mole fraction of this A in this solution. Similarly here P naught B chi B plus P naught A chi A. That's it. That's it. We are done with this. So next, so Ya will be equals to how much? Just substitute the formula, I mean data given. P naught A is how much? P naught A is given as 400 into chi A is how much? 0.7, and P naught B is how much? 600, and chi B is how much? 0.3, and plus P naught A is how much? Again 400 into 0.7. That's it. Okay. So how much will be our answer here? So you can remove this. So 428 0, and here it will be 180 plus 28 0. Okay. So that's it. So you will get 280 by 0.64, 460. Okay. So it will be how many times? See, just take here 0.6 will be around 0.6, like that we'll get. See, here we have 0.69 as our answer. So Ya is 0.609, then Yb will be, sum of their mole fractions are equals to 1 now. So that will be 0.391. That's it. So this will be your perfect option for the question. Hope everything that we have discussed till now here are very clear right now. So there is no confusion, nothing, right? Right. Let me show you few more questions. You can see these questions and you can try them. If you are really facing difficulty, watch the previous live session where I have covered these questions. Whatever I am showing here, you just look into it once. This one, this one. See, I can tell you that, so there is no channel in Telugu community who are discussing this many PYQs with complete clarity discussion, clear-cut discussion of complete chapter. Okay, so I think we have covered this complete solution chapter very well in a crystal clear manner for your upcoming EAPCET exam. Okay, so you can watch these videos and make it more effective preparation. Okay, so thanks for watching. Stay connected with this NEET World channel. Thank you. One new subscriber.